Welcome to Get Your FRQ On. This question is from 2008, Form B. It's question 2, and it is calculator active. In the question stem, we have a function r of t, which represents the speed in kilometers per hour at which a car travels along a straight road. This function is good for values of t greater than or equal to 0. The number of liters of gasoline used by the car to travel x kilometers is modeled by a different function, g of x. In part A of this question, we are asked how many kilometers the car travels during the first 2 hours. The number of kilometers that the car will travel in those first 2 hours can be found by calculating a definite integral, the integral from 0 to 2 of r of t dt, which is the integral from 0 to 2 of 1 minus e to the negative 10t squared dt. Since this is a calculator active question, we're going to use our calculator to evaluate that integral. The integral from 0 to 2 of r of t dt is the integral from 0 to 2 of 1 minus e to the negative 10t squared dt, and that turns out to be 206.370. So in the first 2 hours, the car travels 206.370 kilometers. In part B of this question, we are asked to find the rate of change with respect to t of liters of gas used at t equals 2 hours and to provide the appropriate units. So this is kind of tricky. The rate of change with respect to time of the number of liters of gasoline used by the car when t is equal to 2 hours can be found, but it does require the chain rule since g is defined in terms of x. But we are asked to find the rate of change of g with respect to time, which is t, not the same variable. So if we set this up, we want to find dg dt. By the chain rule, that's going to be dg dx times dx dt, which is dg dx times r of t, since r of t is dx dt. So what we need to find is dg of dt at t equals 2, which is dg dx when x is 206.370, the value we found in part A, times r of 2. And since this is still a calculator active question, we're going to use our calculator again. dg dt when t is equal to 2 is dg dx when x is equal to 206.370 times r of 2. That gives us 0.050 times 120, and that turns out to be 6 liters per hour. In part C of this question, we are asked how many liters are used when the car reaches 80 kilometers per hour. All right, so if the car's speed is 80 kilometers per hour, that means we need to find a value of c greater than or equal to 0 such that r of c is equal to 80. And since this is a calculator active question, we're going to use our calculator. We want to find a solution to the equation r of c equals 0 using our calculator. This implies that c is equal to 0.331453 hours. Next, we need to find out the position of the car after 0.331453 hours. That will be the integral from 0 to c of r of t dt. That turns out to be 10.794097 kilometers. That value, 10.794097 kilometers, now gives us a value of x to substitute into g of x. So we're going to find g of 10.794097, and calculator active question, we're going to use our calculator. Turns out to be 0.537 liters of gasoline. If you like the AP Calculus free response question solutions and want more of them, don't forget to like the videos, subscribe to the channel, and you can also find me on X at x.com/getyourfrqon.